Hello and welcome to the third video in this series on preparation for the Edexcel Medicine Through Time topic. Today we're going to be looking at medicine in the 18th and 19th century in Britain. This is also referred to as the Enlightenment period. So in terms of starter activities, on the sheet that I have attached at the bottom of this video, can you just pause this video and make a note of everything you can remember about each key individual during this period. For the rest of the session as well, I would recommend you have some line paper as well. Just if I mention something which is not to do with one of these key individuals, then you can always add some extra notes. So pause the video, make a note of everything you can remember about each key individual. Okay, so hopefully you've paused and you are now on the you can see my new slide now. So what we're now going to look at is we're going to start thinking about ideas about the causes of disease and illness and how they changed. So just an overview is that the theory of the four humours had been abandoned. Most religious explanations had been abandoned. But still quite a few people believe in miasma. So Florence Nightingale, who's one of the most famous people during this period, she is actually still believes in miasma. But most kind of scientists and people who are investigating the spreading of illness are starting to kind of get rid of miasma as a theory at this time. So the Enlightenment period can be summarized as a time of rapid change with new radical ideas emerging, and that's something that we see in medicine for sure. There was also a time of urbanization, so that means people were moving to the cities in huge numbers, which leads to the spread of new infectious diseases such as typhoid, smallpox, tuberculosis. That's all a product of this rapid urbanization, because a lot of people are living in close, confined areas, so they're spreading illness. So the first person we need to think about is Louis Pasteur and germ theory. So before Pasteur, most scientists believe in something called spontaneous generation. You need to know what that is. So basically they would look at something that was rotting under a microscope and they'd be able to see that it was crawling with microbes. But their conclusion was that the microbes were the product of decay and not the cause of it. Pasteur comes along and he tests some liquids known as nutrient broths in flasks, and he discovers that it's the other way around. So the microbes are the thing that causes decay and disease and are not the product of decay and disease. He also discovers that the air is full of these microbes and that microbes can only be destroyed through pasteurization, so basically through heat. Okay, just to kind of reinforce that, because it can be kind of quite complicated. So if you picture a rotting apple, all right, if you looked at a rotting apple under a microscope, it would be covered in microbes and bacteria. Now, under the old theory of spontaneous generation, scientists would have said that the rotting fruit created the microbes and that these microbes were spread via miasma, and that's why you would fall ill. Okay, so that's why the governments made a big effort of cleaning the rubbish off the street. Pasteur flips it all. So he says that it's the microbes themselves which are causing the fruit to rot in the first place. Okay, and he claims that the microbes are spread through the air. So everywhere around us, the air that we're breathing in is full of microbes. So kind of what this is a classic example of one of the experiments he does. So he has two liquids there. He boils both flasks. He waits, and in the flask where there is, if you look at number 1, in the flask where there's no air getting in, there's no microbial growth. There's no bacteria that grows, and that's because it's not been exposed to the air. Whereas in the second one, where he basically smashes the lid off the flask and exposes the fluid to the air, then bacteria starts to form because again the microbes can be found in the air. Okay, so Pasteur, initially his ideas are not accepted in Britain. So Dr. Henry Bastian disagrees with him, and he was really famous doctor at the time. And the only people that kind of really agree with Pasteur are lesser known scientists. So John Tyndall is one of them, but he's not actually a doctor, he's a physicist. So people don't really listen to him. And Joseph Lister also agrees with Pasteur, but again, Joseph Lister at this point, he wasn't as well known as Dr. Henry Bastian, and he had no scientific explanation to support Pasteur's work. So he agreed with what Pasteur was saying, but he didn't have enough scientific proof to be able to confirm it. But along comes Robert Koch. Okay, so Robert Koch, he develops Pasteur's ideas by discovering the specific types of bacteria which cause disease. Now Pasteur, you need to know this, Pasteur spends most of his time focusing on, you know, decaying fruit, decaying liquids, decaying food, essentially. Okay, what Koch comes along and does is he focuses on disease itself. So he tries to link bacteria to diseases. So these microbes that you can see under a microscope, he tries to link that to illnesses or specific illnesses. So he discovers that there is a microbe always present in cases of tuberculosis, and he also identifies a microbe responsible for cholera and anthrax. If you were trying to target a higher level, you need to know a little bit more about Robert Koch. So what he does is he grows his bacteria in something called cultures, which are like kind of a petri dish. So he basically puts bacteria in a dish and puts it in the perfect conditions for that bacteria to grow. He then kind of color codes the bacteria, so he stains them to make them easier to identify. And then he basically would examine multiple patients with the same symptoms. And because he's, you know, color coded the bacteria, he's able to identify the reoccurring bacteria. Okay, so the ones that keep coming up, and that enables him to see which microbes cause which illness, which ultimately means that the doctors can now focus on getting rid of the microbe as opposed to just treating the patient's symptoms. So Koch himself changes science in the sense that people are now focusing on the disease itself, and he makes Pasteur's theory relevant to the field of medicine. Right, we're now going to move on to treatment and prevention. So we're going to start off with surgery. Now, before the 19th century, there were three main problems with surgery. So bleeding, pain, and infection. In the 19th century, so in this period that we're looking at, though the second and third problems there are dealt with. Okay, so there are solutions to pain and solutions to infection. Bleeding, the solution to that comes at the start of the 20th century. So let's focus on pain first of all. So your man to remember for pain is James Simpson. So before Simpson, there had been some discoveries relating to pain relief. So people were using laughing gas or chemical ethers to kind of prevent pain during surgery. But both of those had really, really bad side effects. So vomiting, dizziness, very, very poor side effects. And they also had other disadvantages as well. So laughing gas only lasted a certain amount of time. So if you were trying to do a more complex and deeper surgery, that's not going to be very good. And the chemical ether was too flammable. Okay, so it was very easy to set on fire. So Simpson believes that there could be better pain relief options out there. So what he and his friends do is they start inhaling the vapors of various chemicals, and they come across chloroform by accident. So they're basically there inhaling these chemicals in a lab, and they all pass out. All right, and they're woken up by Simpson's wife the next morning. So what they actually discover from that fact is that chloroform had the potential to make a person fully unconscious. Okay, and that's the reason why we call chloroform the first ever true anesthetic. It then spreads widely, and even Queen Victoria uses it when she was giving birth in 1853, which leads to a lot more people trying out chloroform. Okay, and chloroform, because it knocks a person out, that means they cannot feel pain, which allows the surgeon to perform deeper and more complex surgery. Okay, so by 1896, surgeons have performed the first heart surgery using chloroform. Okay, so that's really, really important. There are a few drawbacks that you need to know. So overdoses of chloroform could kill a patient. So Hannah Greener, very famously, was a 14-year-old girl, and she was the first person to ever die from chloroform. And it could also trigger heart conditions or heart problems as well. We're now going to move on to infection. So this is the other problem with surgery that you need to know about for this period. And until the 18th century, operating theatres were incredibly dirty places. People had little understanding of the importance of hygiene, and it was often said that the amount of blood stains on a surgeon's apron was a sign of how experienced they were as a surgeon. Lister, who'd read the works of Pasteur, observed that the flesh around wounds were rotting, and he theorized that it might be from microbes in the air. So he would look at a wound under a microscope and would see the microbes crawling over the wound, and he thought, well, actually, this rotting flesh around it, this dying flesh, is actually being caused by the microbes. So what he does is he tries to find a chemical that would kill these. And after experimenting on a patient with a broken leg, he discovers that carbolic acid cleans the wound fully. All right, and that is the first ever antiseptic. So it gets rid of all the microbes and bacteria around a wound, which then prevents infection. All right. So Lister then starts to spray carbolic acid on wounds. He sprays it in the air as well when he's operating, and that further reduces the amount of patients developing infections. And then linking in with what we did in the last video, thanks to the printing press, he publishes his results in a scientific journal called The Lancet, in the hope that his ideas would spread. But they don't. So at first there was some resistance to his ideas. So germ theory was still doubted, carbolic spray dried out the skin, so people thought it was unsafe. And I mean, Lister himself gives up on carbolic acid because of the side effects. But we need to think about his impact more in the long term and not in the short term. So his impact is all about changing attitudes towards surgery. So now, surgery, it was expected for surgery to be a safe procedure, okay? A procedure without infection, all right? And his surgery, the fact that he discovers antiseptic helps lead to something called aseptic surgery, which is what surgeons are practicing at the start of the 20th century. So that is where efforts are made to sterilize all equipment and the operating theatre to prevent infection in the first place. Okay, so instead of having to use antiseptic to kill off the germs, it's all about making sure hands are washed, all equipment is sterilized, all sheets are clean, to prevent infection in the first place. So we call that aseptic surgery. So that's all about preventing infection in the first place. We then move on to Florence Nightingale and hospitals. So before the 19th century, there weren't many hospitals in Britain. The ones that did exist had the following problems. So high infection rates, which led to death, poor sewage systems, untrained nurses, unclean equipment, and a lack of personal hygiene. So Florence Nightingale, she's a nurse from a very middle-class background, and she spends the part of her early career in the Crimea. So in Crimea, she does the following. Okay, you need to know a couple of pieces of evidence for the exam for what she does in Crimea. So she makes nurses carry scrubbing brushes to basically clean areas around where patients are being treated. She provides clean bedding and good meals for the patients. And she starts to train nurses. Okay, that's really important. When she returns to England, unlike her kind of counterpart Mary Seacole, she's able to introduce a lot more changes. Okay, thanks in part to her race. Okay, so first of all, she makes sure that hospitals had better ventilation through windows. She makes sure that different wards are separate and isolated so that the spread of disease is limited. She encourages the use of antiseptics to help keep everything clean. And then importantly, she creates a nursing school. She created a nursing school called the Nightingale School for Nurses in 1860. Okay, so now nursing becomes a more respectable occupation because the women who are nurses are now trained. The key thing to remember though with Nightingale is that she does believe in miasma. So ventilation, her big emphasis on ventilation, we know it to be important because it prevents the spread of microbes in the air, but she believed, well, actually it was getting rid of bad smells. Okay, so that's why she insisted on having windows. So we need to think about the impact of Florence Nightingale after this. So initially, the government listens to her advice. They follow her design of hospitals, which is known as the pavilion model, kind of emphasizing ventilation. Hygiene becomes more important. Doctors and nurses are now training in the hospitals instead of just being, reading books in a university. Doctors are now actually learning on the job. And there's now a focus on treating the sick as well. Before this, hospitals had just been kind of viewed as a place for the sick to rest. So the treatment they were getting wasn't very effective. However, many of the poorest still couldn't afford hospital treatment, so continued to be treated in the home. And that's something to bear in mind, all right? So Florence Nightingale makes all these changes, but if you're just an ordinary person living at the time, you're probably not going to benefit massively. And then the final individual, before we move on to the case study of cholera, is Edward Jenner. Okay, so we're now going back to the start of the 18th century. Start of the 19th century, end of the 18th. And basically smallpox had been a huge problem throughout the 18th century. And people had basically been practicing something called inoculation, all right? And this often gets confused with vaccinations, but it's different. So inoculation is where a person was infected with the virus in order to avoid a worse case later on. So let's say, for example, you had somebody who didn't want to catch a really bad case of smallpox, so they would be inoculated with smallpox, just a normal case of smallpox. This is different from vaccination, because vaccination, as developed by Pasteur and Jenner, is actually all about giving a weakened version. Okay, and more on that later. All right, so I'll explain that in a little bit more detail later. Okay, the key thing to remember with inoculation, though, is that it didn't always work. Okay, because the impact of the dosage varied. So a case of smallpox injected into person A might not have any effect, but when given to person B, who has a weaker immune system, they might die from it. Jenner comes along and he notices that dairymaids in Gloucestershire weren't catching the disease if they'd previously had cowpox. So he takes a young boy called James Phipps. He infects him with cowpox, and 6 weeks later he attempts to infect him with smallpox. But James didn't catch it, all right? And that's because his body has developed immunity. So people were initially really against Jenner in the short term, all right? So he couldn't explain why vaccination worked. The church was annoyed that he'd been using animal infections on humans, so inserting cowpox into a human being. Inoculators were worried that they would start losing customers and losing their source of income. And the Royal Society refused to publish Jenner because they were sceptical about the science behind his discovery. But overseas, so in France, Jenner's discovery has more of an impact in the short term. So Napoleon actually has his entire army vaccinated in 1815. But if we come back to Britain, we can say that in the medium and long term, Jenner is actually very successful. So the government makes inoculation a crime in 1840, and they agree to provide children with smallpox vaccinations. And then the government then makes vaccinations compulsory in 1852. Okay, that's the date you want to remember. So smallpox vaccinations are made compulsory in 1852. In terms of Jenner's impact as well, he inspires others to identify new vaccines. So Pasteur creates a vaccine for anthrax, and Pasteur develops Jenner's idea. So he starts giving people a weakened version of the same disease. So if you take smallpox, for example, he would have given... Pasteur didn't work with smallpox, but if he did, he would have given a weakened version of smallpox to patients. Okay, and because it's weaker, it's not going to have as much of an effect on them. That then triggers an immune response. The body creates antibodies. So if somebody is ever infected with smallpox again, they have immunity, which means they cannot fall ill. Okay, just before we finish by looking at John Snow and cholera, you do need to know about something called the Public Health Acts. Now, although these are not individuals, I have included space for them on the sheet. So you do need to know about them. So there's two Public Health Acts. An act is like another word for a law. And the first one is in 1848 and the second one is 1875. The first one basically recommends that councils improve the quality of the hygiene in their area. But the key thing is that it's not compulsory. Okay? It's not compulsory. There's some more information on the screen as well for 1848 if you are targeting a higher grade. For 1875, the recommendations are now compulsory. Okay, so they're no longer recommendations. People have to follow the advice that is given now. Okay, so the local councils now have to provide a clean water source. They have to have an effective sewage system. They have to provide public toilets, street lighting, and public parks for exercise. That is compulsory. Okay, there's no way that they can get around that. Okay, I know it's been a long video, but we're now at the final case study. Okay, or the final piece of information you need to know. So John Snow and cholera is what we're going to finish with. So just a bit of an overview of cholera. It's an incredibly deadly disease at the time. It led to extreme diarrhea and sickness that often resulted in death. So in 1848 alone, in just Britain, there were just over 50,000 deaths from cholera. So John Snow theorized that cholera couldn't be transmitted by miasma, okay? Because miasma is bad air, and for it to be transmitted by miasma, that would affect a person's lungs, okay? Because it's bad air, a person would have to breathe it in. However, cholera affected a person's guts, all right? So Snow worked out that it couldn't be passed by miasma. So that was an important discovery. What he does is, when it breaks out in London near where he lives, so he lives in a place called Soho, he basically identifies where all of the different deaths in his local area take place. And he basically identifies that all the deaths are converging around somewhere called Golden Square and Broad Street. And where those two streets meet is the Broad Street pump, okay? So it's a water pump, all right? So he theorizes that all these deaths are linked to the water pump on Broad Street. So he thinks that cholera is a waterborne disease. Now, this is important because everybody beforehand had believed cholera was transmitted by the air. Now, people were starting to think, well, actually, or people who were listening to Jon Snow started to think that cholera is actually being transmitted through the water, which is a radical idea. So what he does is he removes the handle from the pump, and that leads to a massive decline in the number of cholera deaths in his area. And people, when they inspected it later on, basically uncovered the fact that the water pump was very close to the nearby cesspit, so less than a meter away. And what was happening was the poo from the cesspit, because the cesspit is where all of the human waste is stored, the poo from the cesspit, some of the particles, some of the just very small fragments of that were going into the water stream, into the water supply, and that meant that people were kind of drinking water which was contaminated. And finally, if you think about the impact of Jon Snow, the government, partly because of Jon Snow's work, decided to introduce a new sewage system. But they're also influenced by a man called Edwin Chadwick, who says that the sewage system is bad anyway. They're also influenced by something called the Great Stink, which is where the Thames, or the sewage in one hot summer, ended up on the banks of the Thames, and the smell was so bad that people were vomiting. And so they employ a man called Joseph Bazalgette to construct the new sewage system. All right. The issue is that many people didn't agree with Snow early on because he couldn't prove his findings. All right, germ theory hadn't yet been discovered or devised by Louis Pasteur, so Jon Snow was struggling to justify and explain his ideas. So his long-term impact was significant, but his short-term impact was minimal. Okay, and that brings us to the end of the video. Now, before I finish, I just want to make some concluding remarks about the Enlightenment, what you need to know. So I would be talking, in particular, I would be mentioning that a lot of individuals have a long-term impact, but their short-term impact is small. Okay, that's very common to a lot of the individuals in the Enlightenment. You also want to talk about how a lot of individuals in the Enlightenment, thanks to the printing press, thanks to other forms of communication and correspondence, are now working together. So if you think about Robert Koch and Louis Pasteur, Robert Koch develops Pasteur's work. Louis Pasteur develops Jon Snow's work, Louis Pasteur develops Edward Jenner's work. Jon Snow's work is linked to Louis Pasteur's because germ theory kind of proves it. So that's very important. They're all linked. And then the final thing you need to know is that the turning point in the Enlightenment period is the germ theory itself, because it confirms Jon Snow's work, it confirms what Edward Jenner had discovered, it confirms the importance of Florence Nightingale's changes to the hospitals, even though she believed in miasma, and as Robert Koch proves, it changes medicine for the better. Okay, so germ theory, if there's ever a question about is germ theory the most important, or is another thing the most important, you need to be arguing that germ theory is the most important discovery, or at least that's how I would argue it. Okay, and then final thing is just be aware that, again, the content in this is not exhaustive, it's not complete. I still think that people who are targeting a 7, 8 or a 9 should be trying to do some extra reading outside of these videos. All right, thank you very much for listening, and I will be coming soon with the next video on medicine during the 20th century. Review of key content, as you can see on the screen there. But again, kind of with all these videos, we have to think about how our ideas about the causes of disease and illness changing during the time. So as part of that, we're going to be focusing on Pasteur and Robert Koch. We're then going to have a look at approaches to prevention and treatment, thinking about Nightingale, James Simpson, Joseph Lister, those kinds of people, as well as looking at Edward Jenner. We're also going to consider, in terms of prevention, the Public Health Act as well. Okay, and then finally, our key case studies for this topic are Jenner, and then fighting cholera. So that will be basically Jon Snow and some information about cholera. Okay.